When 50 grams of silicon dioxide, so we're told we have 50 grams of this stuff, is heated, so maybe we should put the delta over the arrow, with excess carbon, 32.2 grams of silicon carbide is produced. So this here is your actual yield. But we need to find the theoretical yield of silicon carbide. And we get that from the limiting reactant, because we're told that the carbon is in excess. So that's your excess reagent. So let's do the stoichiometry to determine the theoretical yield of silicon carbide. Start with what's given. 50.0 grams of silicon dioxide. First step in stoichiometry is to convert to moles. We're given grams. Once we get to moles, we can take that to any other substance in this reaction. So we need a conversion factor to get rid of grams of silicon dioxide and end up with moles of silicon dioxide. The conversion factor we'll use is the molar mass. That information is right off the periodic table. So 28.09 plus the 2 oxygens is 32. And we'll take this out to 4 sig figs. That way we can round down to 3. So the molar mass of silicon dioxide is 60.09 grams per mole. Cancel the units, top and bottom. And now let's use the mole ratios to convert to the desired substance. Right now, we have information in terms of silicon dioxide, and eventually we need to get that information into silicon carbide. So the mole rate, we forgot to balance this. Well, let's see if we can balance this without having to do a lot of side work. We got carbons appearing on multiple places on the right, so let's do that last. Silicons are good at 1 apiece. Oxygen, there's 2 on the left. We need to put a 2 there in front of the carbon monoxide to balance the oxygens. And now we can take care of the carbon. So that wasn't bad. Turns out that wasn't even necessary, because the 2 substances we're going between have the same coefficient of 1 and 1. So 1 mole of silicon dioxide will give us 1 mole of silicon carbide. Cancel out the units that appear top and bottom. And I want to copy this so we get a little bit more room. Or move it over. Now our final step is to convert to the desired unit. I believe the question was asking for grams. Oh, I didn't read the question because we're doing part A. Okay, what is a percent yield? So we need to get the theoretical yield in terms of grams, because the actual yield is in terms of grams. And since this is a solid, what else would it be? So let's convert to grams. Moles to grams. That's off the periodic table. Now, silicon is 28. I'll do this in a slightly different shade. And then there's 1 carbon, which is 12.01. So the molar mass of silicon carbide is 40.10 grams per mole. All right, let's punch these numbers in. 50 divided by 60.09 times 40.1. We need 3 significant figures. So 33.4 grams of silicon carbide, and that's our theoretical yield. Now part A is asking us, what is the percent yield? What is the percent yield? So percent yield is the actual yield over the theoretical yield times 100. So we're given the actual yield of 32.2 up here. 32.2 grams over the theoretical yield is why we did the Stoich. I'm going to copy this so I don't use rounded numbers. 32.2 divided by times 100. 96.5 is our percent yield. So that's our answer to part A. Now let's go to part B. How many grams of carbon monoxide are made? Well, that's a completely different question. So we have excess carbon. So the limiting reagent, in this case the silicon dioxide, is going to determine either one of our products. But now that we have the theoretical yield, we can use that and take it to our answer as well. So there's a couple ways you can do this. I already have the molar mass of silicon dioxide, so I'm just going to use that. But what I'm saying is you could have started with here, with the mass of silicon carbide, and got your answer. But I prefer this because I already did all of this. I'm just copying from what I did earlier. Now the mole ratio is different because for carbon monoxide, we get 2 molecules or 2 moles for every 1 molecule or 1 mole of silicon dioxide. And let's just double check. It's asking us for how many grams of carbon monoxide. So the molar mass, carbon is 12.01 and oxygen is 16.00. The molar mass of carbon monoxide is 28.01 grams per mole. So that's going to be our conversion factor. Let's punch these in. 50 divided by 60.09 times 2 times 28.01. And so our answer is 46.6. grams of carbon monoxide. And that's your answer to part B.